In this lesson, we will use the free online graphing calculator linked below to graph a function, adjust the window, determine the local max and mins, as well as determine the open intervals for which the function is increasing or decreasing. The first step is to enter the equation into the calculator, and the calculator does use function notation, and therefore we will let y equal f of x. So going to the calculator, the first step is to clear the existing functions. And we have f of x equals negative 2x cubed plus 42x squared minus 270x plus 11. Remember, the exponent key or caret is shift 6. Now click plot graphs. Right away, notice how we do not have a nice viewing window because we don't see the high and low points of the graph. We can try zooming out by clicking on the minus in the lower right hand corner, but this doesn't help. In this case, we will have to adjust the window manually. Before we do this though, it can be helpful to analyze a table of values to know how to adjust the window. Let's click the table tab at the right. We will leave the x values on automatic. Let's start x at, let's say, negative 5, and we'll leave the step at 1, so x increases by 1 as we go down the table. Click go, and now let's analyze the y values as x increases. Notice how the y values are decreasing. And it's a little hard to tell, but somewhere between 4 and 6, the y values change from decreasing to increasing. From negative 525 to negative 539, the y value decreases, but then from negative 539 to negative 529, the y value increases. So we want to analyze the graph when x is between 4 and 6, and y is somewhere between negative 500 and negative 550. As we progress down the table, the y values continue increasing until somewhere between 8 and 10, the y values start to decrease again. When x is 8, y is negative 485. When x is 9, y is negative 475. So y is increasing, but then at x equals 10, y is negative 489, which is decreasing. So we're also concerned about the graph when x is between 8 and 10, and y is somewhere between negative 450 and negative 500. Let's use this information to adjust the window. Click Window. Let's have the x values go from, let's say, 2 to 12, so they include the x values from 4 to 6 and 8 to 10. And let's change the y min to, let's say, negative 600, and the y max to negative 400. Let's click Update and check the window. Notice now we have a very nice view of the function. We can see the low point on the left, which represents a relative minimum, as well as a high point on the right, which represents a relative maximum. However, sometimes we do want to see the origin of the graph, so let's adjust the window again. Let's change the x min to negative 2, so we include x equals 0, and let's change the y max to 100, so that y equals 0 is included. Again, this is optional, but if we click Update, notice now we can also see the origin. So we could use the previous window or this window to determine the relative extrema, as well as determine if the function is increasing or decreasing. Let's go ahead and use this window. Let's find this low point here on the left. To do this, we click on the Calculation tab. From the drop-down menu, click Minimum, and then we're told to draw a box around the minimum. We click, hold, and drag to form a box that includes the low point of the graph. Release the mouse, and the ordered pair of the low point is given. We have 5 comma negative 539, which means we have a relative minimum of negative 539 at x equals 5. Notice the information is also recorded on the left. And now let's find the high point on the right, which will give us a relative maximum. Go back to the drop-down menu, select Maximum, draw a box around the high point, click, hold, and drag to form the box, then release the mouse, and we have the ordered pair for the high point. We have a relative maximum of negative 475 at x equals 9. Also notice how reading the graph from left to right, the graph is decreasing from negative infinity to x equals 5. Then from x equals 5 to 9, the graph is going uphill, and therefore the function is increasing. To the right of 9, or from 9 to infinity, the graph is going downhill, the function is decreasing. Let's go back to our work and record this information. Again, we had a high point at 9, negative 475, and a low point at 5, negative 539, which means we have a local maximum of negative 475 at x equals 9, and a local minimum of negative 539 at x equals 5. And now to help us determine the intervals for which the function is increasing or decreasing, let's sketch a number line, plot open points at x equals 5 and x equals 9. A function will always change from increasing to decreasing or decreasing to increasing at the relative extrema. And again, going back to the graph one last time, from left to right, the function is decreasing, increasing, and then decreasing. So we have decreasing over this interval, increasing over the middle interval, and decreasing to the right. So using interval notation, to the left we have negative infinity, to the right we have infinity. So the function is increasing on the open interval from 5 to 9. And the function is decreasing on the intervals from negative infinity to 5, union from 9 to infinity. If we wanted to use inequalities, we could say the function is increasing over the interval where x is greater than 5 and less than 9, and the function is decreasing when x is less than 5 or when x is greater than 9. I hope you found this helpful.